I'm going to turn on my camera briefly so you can all see my face. My name is Ademola. I'm the MD of Lotus Beta Analytics. It's a great pleasure to be here. I warmly welcome you all to this event. I trust that it will be valuable to the community as they partake in the event. Please feel free to invite your friends, colleagues, and anyone who is starting up a business, a tech business, because the objective is very simple. We want to give you access to 3 key things. Number one, access to bleeding edge technology from Microsoft. Secondly, we want to promote or give you the opportunity to also get access to local and international technical expertise that this program is going to deliver. And third, not the least, is also access to a number of funding possibilities by connecting you to seed investors that can support startups. So that's the main goal of all of this, is to support the startup community. But if you're a developer and you're just a budding developer, this is also good for you to be here at the same time. So without further ado, I'm going to start the session by taking you through lean and agile mindsets. I'm just going to talk about those things briefly before the technical guys come in to talk more about the technical aspects of building lean and agile product with DevOps. So I think you need to make me a presenter, Ayomide. I think you urgently need to make me a presenter because I can't share my screen right now. So if you do that, then I will be able to share my slides and start. Right. Okay, so screen. Thanks. All right, like I said, I have a number of slides. I'm going to run through that very quickly. I'll try to compress it within about 20, 30 minutes to see if we can go through that. There's quite a bit to cover there. Please confirm that you guys can see my screen.
Yeah, it's visible here.
All right. So I'm going to talk about, business agility in the digital age. I'll browse through that quickly. And I'm going to talk then delve into business agility itself. And how do you get your business to become agile? And speak a bit about lean and agile mindset, and then talk briefly about solutions with agile product delivery. Yeah. And then summarize and take questions from there. So Mick Kesson, he said, those who master large-scale software business will define our economy landscape today. Yeah. So today, it's practically software that is software development that is driving the economy. If you look at the top 3 big companies, big companies in the world, you may say they are logistic companies, you may say they are whatever it is that you may call them, they have a software delivery back end that is driving that business. So it's very important for you to understand, for all of us to understand that we're in the right place and in this age. Software delivery is very important. Yes, of course, people have moved from all these, different technology revolutions, and we are now in that age where software and digital is what it is. And what is driving, finance capital today is really around, just how great it is that the software, how great that software is behind that solution or that product that you're providing. Whether it is Tesla that you look at, 70 to 80% of whatever Tesla is doing, Amazon is doing, is controlled by software. So if the software isn't good, then it's going to be a problem. Boeing had a problem in recent time with a remodeled version of their aircraft. And what was wrong? What was the problem? It was software, and that took down that resulted in 2 plane crashes in the past 5 years. So it's important to know that today software people and software businesses are doing a great deal in the market that we are in today. I mean, think about it. Apple is the biggest watchmaker in the world. It's not Omega or G-Shock as we know it before. So your organization, you need to start rethinking the way you look at how you deliver. You need to look at the systems, structure, and culture that you're using to deliver the service that you are delivering. So when you think about it today, customer is on one side and a bit of network of all the things that you're doing are on the other side. And your internal delivery mechanism or execution needs to be set up in such a way that it works all over your organization. In the case where where you just have that one-to-one mapping without a proper process in between, it's just chaos, which is what happens here that you see. But where there is efficiency and stability, as things move around, as things change, where you have speed of execution and innovation, and there is business efficiency and stability, based on the agility of your business, you see continuous flow of service to the customer with minimal disruption. Yeah, so that the customer begins to see value stream, properly mapped value stream, and orchestration with your with the entirety of your business. Every business is a software business now. Achieving a state of business agility means that the entire organization, not just the development team, is engaging continuously, proactively delivering innovative business solutions faster than the competition. That's a statement of fact. You just have to. Business agility requires not just technical agility, but also business level commitment to product and value stream thinking. You need to think the product, you need to think what value are you going to get into the hands of your customers at the shortest possible time. So when you look at all of these things, whether you're in operations, business, this is a holistic way to think as when you start thinking about the product that you're turning out there. It requires everyone involved in delivering a solution to use the lean and agile process. Why? So why use lean? If you ask me today, those who use this methodology, who use this framework, who use this practice, who have this mindset, they are able to deliver products that are 50% less defective. So you have quality built into the product. There's 50% faster time to market. 50%. Just imagine it takes you half the time to get your products out there because you're building in quality right from the get-go. And productivity increases by 35% plus, and then you also have happier customers, than you did before. So what is exactly the business agility? What exactly is? What are the frameworks of it? I mean, what are the pillars of it? What does it entail? So there are about 7 or 8 things that you want to, at the core is the customer. All of it bevels into delivering some form of value to the customer. So you've got these 7 things that you need to always think about. Organizational agility. how your organization is able to respond to changing requests or requirements that keep coming in from the customer. So that's one. Two, how do you manage a lean portfolio? Three, enterprise solution delivery. So you need to make sure that at the end of the day, the customer is just interested in the product. Then there is also the agile product delivery itself. Team and technical agility is also very important. And then a lean agile leadership, the leadership team that comes together in delivering this product must be lean and agile compliant. And then last but not the least, obviously, is a continuous learning culture. So you have to have a culture where you're continuously learning and growing and improving yourself. So let's talk a bit about some of these, pillars that I've mentioned. We're not going to talk about all of them because of time. Well, I've mentioned what team agility, technical agility means. It's just ensuring that you've got cross-functional teams that are highly performing, whether they're business or technical, coming together and building solutions, quality solutions that make customers happy. That's just simply what it is. Just having those cross-functional teams performing very high. How about agile product delivery? Again, here we're talking about customer at the center of whatever it is that we're doing, and then breaking down those value streams and be able to release them. And I'll show you briefly the fact that the fact that you're able to do this helps you to give the customer some version of value. The statement is made about value stream. So it's very important for us to understand value stream and see how you're able to deliver a bit of the product to the customer. When you do that, you give them value, you shorten your time to market, and you have something in their hand, and then you release another version of it, and then you increase the value that you're there. So you start earning money and you start earning customers very early in the day, continuously exploring and integrating and developing and then releasing the product. That's the agile product delivery mindset. We'll talk more about that very briefly now. So how about enterprise solution delivery? So we're talking about lean system engineering practice to build real complex projects, coordinate and align supply chain, continue to, enhance value even after you've released the product. So you are in a live contract with the customer, continuously deliver value to them based on the product that they have in their hands or they are using every day from you. The next one is about lean portfolio management. Here we're talking about the organization from a strategy investment fund and investment funding perspective, from a governance perspective, and also from an agile portfolio operation. So you're talking about lightweight empowerment, lightweight governance that empowers the staff and decentralizes decision making while you are optimizing operation across your portfolio. So and this bevels up into your organizational agility, which creates enterprise level lean and agile mindset around the organization. Maps continuously and improves the process that you use in the organization. So you're talking about improving continuously whatever it is that you're doing and delivering for your team. It's really around strategy agility and lean business operation, where it's really about what's the value that we want to deliver now in simple terms, and how quickly can we deliver it. It's quick and dirty and it's delivered now. For us to cost correct it after we've released it in the hands of the customer is enjoying some value right now, and something else is going to hit them very shortly, and that whole synergy between your organization, the product, and the customer, continuously being able to also giving you that ability to see what is inside of the mind of the customer when your product is in their hand. When your product is in their hand and you can see what they're thinking of, bigger opportunities become open to you, and you're able to take advantage of those opportunities and sometimes mitigate those threats. Yeah. So continuous learning is part of the DNA. It's exploring the creative part of the organization to continuously improve the solution or service or the process that you use in delivering the solution to the customer. It's everyone in the organization learns and grows together faster. When you come together and you have a culture of innovation and you're seen as a learning organization, relentless improvement is your watchword. You begin to see that permeate into the products that you're putting out there. Lean agile leadership also, it starts from the top. You inspire and you be the example that people in the organization follow. You live the values and principles, not just from a word of mouth perspective, but also from being the example that people can follow. Yeah. So management challenge. It is not enough that management commits themselves to quality and productivity. They must know what it is they must do. Such responsibility cannot be delegated. You have to come to the table with clear-cut understanding of what needs to be delivered. And there's also the opportunity for you to provide assessment of what it is that you have done. So all of these things that we've talked about, you need to continuously ask yourself, and you can create a table that can help you assess yourself and assess your organization, where exactly you are in the scheme of things. All these 7 core competencies that I just briefly described. Just find out where you are there, and then see what course of action you can take to improve them. Let's talk a bit about lean thinking. Yeah, precisely specifying value product. That's lean thinking. It's a 3-step approach where you've got an idea that comes up in your mind about a product or about a solution, and then you specify the value for that product. You identify the value stream, and then you make the value flow without any interruption to the customer, while you also allow the customer pull out more. And this is what I mean by saying, when the product is in the hand of the customer, you're also able to see the additional thinking from the customer that provides you some kind of feedback. And then you go back and you redo all of that all over again. And then you turn out another great product in the hand, another version of your product in the hands of the customer, and you increase the customer. Either they're going to pay a bit more for it, or it's going to make the product become more popular, and so on and so forth. It's about banishing waste and creating wealth in your corporation. That's what lean thinking is really about. And this is the way to build lean thinking. Or a mindset. It's the spearhead, the arrowhead of it is value, the value that you're putting in the hands of the customer. Don't forget, everything we do is geared towards the customer. And the bedrock of it is the leadership that you have in your organization. These other 4 pillars just sit in there, and they help you provide the approach, the right approach to lean mindset. So I'm not going to talk too much about this again. I just want us to understand that this is the way you think about it. Value. What is value? It's the best quality. Is achieving the shortest sustainable lead time with the best quality and value to the customer. High morale, safety, and delighting the customer. There's only one boss, I always say to my staff, and that's the customer. They can fire everybody in our company, including myself. There's only one boss. How do they fire? They will just take their money and go and spend it somewhere else. So you must be asking yourself, what we're delivering, is it going to deliver value? Is there a value stream there? That is there another thing that these guys are going to want and we can deliver on top of what we have providing for them? So I'm going to talk about the 4 pillars quickly. So respect for people and culture. Sometimes people think that in Nigeria or in business, you don't really need to care about for people, whether people internal or people outside, and the culture is very important for us to consider that and to take care of that. Culture eats strategy for breakfast, Peter Drucker says, because people do all the work. Consumers are people, so your consumers is whoever consumes your work. So you need to build long-term partnership based on trust, and making sure that they can trust what you've got in the product. And you can write a good code, but if the code keeps breaking, then it's of no use. It's not going to scale. You're not going to get 100,000 people downloading the application, the mobile app. So you need to do it very well and do it very well every time. Okay. In terms of flow, we're talking about operating a product development process near full utilization of the resources that you have. So always looking at how you build quality inside of what product that you're delivering, and how optimizing how that value stream is being delivered to the customer. That's the flow. Understand, exploit, and manage any variability, any change, that helps you move your ideas into projects, and then they finally become product in the hands of customers. And then you repeat that cycle all over again and again. Innovation. This is the engine room where everything stems from. Innovative people drive businesses, come up with great ideas, provide space and time for innovation. You also need to go out there and see, experiment, feedback, get into the footsteps of the customer, so that you can get ideas that can help you innovate appropriately without any issue. Last but not least, in the pillars that we have is the relentless improvement. If you stop innovating and you don't want to improve your product, you're just going to fall off, and nobody's going to buy your product. And for example, you can ask Kodak about this. They stopped innovating, as people stopped buying films, and that's it. Photographic films, people stopped buying it, and that's it. Their business is dead. They went out. So you continuously need to continuously innovate. Understand that it's a constant sense of danger. Those who adapt the fastest win. Very simple to understand. So you need to relentlessly seek improvement in whatever it is that you're doing. And this is a mindset that you need to have when we're talking about lean and agile business agility framework. Last but not the least is a leadership bedrock, which is, I'm not going to call it a pillar. The pillars are the ones standing, while the bedrock is the leadership bedrock. People are already doing their best. The problem with the system, the problem is with the system, only management can change that system. So as leaders, you have to be plugged in. You have to be able to adapt as things change. You have to be the lead, be the example of the values of the lean agile principles. You have to be that example by leading by example. That's the only way it's done. If you call for a stand-up meeting for 8 a.m., you have to be there at 8 a.m. You just have to be there. You have to lead the change, and make people feel safe and trust them, empower them and trust them. Let them do what they're supposed to do. If they're going the wrong direction, you course correct them. If they're doing the right thing, leave them and let them do their job. Yeah. So when you look at all of these things that we talked about in terms of a lean mindset, you can always put it in this and review your organization, your team, and saying, where are we exactly in the way we're delivering value to our customer, in the way we're working as an organization. Yeah. So let's quickly go to the to the Agile Manifesto. Simply put, it's just these 4 things. There's about 12 of them, and I'm not going to talk about all 12 of them, but if you understand these 4 things very well, then you will understand what the Agile Manifesto is really about. It is about individuals and interactions of individuals more than just processes and tools. So yes, there's process involved, there are tools involved, Kanban and all those other things that you're going to hear about, but it's about getting people to interact and about those people. So you must put those people and interactions far above the process and the tools. Augment wherever you need to. The second one is working software over comprehensive documentation. It's important to document. We're not saying take away documentation, but we're saying that we must prize working software far above just a mere detailed documentation of what it is that you've done. It is also about customer collaboration over contracting. So it's not important, we know that there's a social contract and all of that, but do you feel that you are part of the customer ecosystem? Do you feel that you're part of that? So it's about collaborating with those customers, and not just seeing yourself as a producer of a product or a solution and just walking away. Yeah. Lastly, it's responding to change over just a plan. As Mike Tyson would say, everybody has a plan until they get punched in the face. So, what are you going to do when you get punched in the face? And we get punched in the face every day. Yeah, the guys at the National Stadium yesterday got punched in the face and they reacted very badly, I would say. So what are we going to do? So it's about what you turn up with. Will Smith reacted badly when he got punched in the face, whereas Chris Rock didn't. He took it on the chin and moved on. So it's in your business, with whatever it is you're doing, you have to have a set of plan Bs, and when stuff happens, what are you going to do next? So this is what we refer to as the Agile mindset, the manifesto, the Agile Manifesto mindset. Our biggest priority is to satisfy the customer through early and continuous delivery of valuable software. That's it. So I'm going to talk about, just talk to you about some of them. Welcome change requirements, even late in development. Agile process harnesses change for customers' competitive advantage. You're never tired of receiving change. There's no problem. This is different from the traditional waterfall system where they see a change and they have to pack it and then deal with it via a change request and all of that. Yes, you will have change requests and you will manage it through that. But Agile thrives based on the fact that, look, when a change comes, it's what's going to help this customer give a better product than the competition. That's what makes Agile distinct. Deliver working software frequently from a couple of weeks to a couple of months, with a preference for the shortest time scale. So it's not about, this is a project, this is what you're supposed to deliver, and you sit down and you say, we're going to do it in 10 weeks. What can we deliver that can be in the hands of the customer in 2 weeks, in 4 weeks, not in 12 weeks? Business people and developers must work together. So this is where we're talking about individuals now, working together daily throughout the project. So you've got a team, a Scrum team. an agile team that, that you're coming together and doing, having daily interactions that help shape the product. Yeah. Next is build projects around motivated individuals. So everybody, the teams that you form are teams of self-motivated people. You give them the environment and the support they need. You leave them because you trust them to get the job done. Those are the principles behind this. So when you have a team, you need to make sure that these teams are working in this manner. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Again, we're talking about those interactions that you're having with the individuals. It's daily, it's face-to-face. At the end of the day, working software is the primary measure of progress. There's no other thing. It's not how many meetings we had. It's not how many people we have in our team. Who is a specialist here and there. It's not the look and feel of the product alone. It's a working, beautiful solution in the hands of the customer. Agile process promotes sustainable development. The sponsor, developers, everybody are able to maintain a constant pace indefinitely. So it's sustainability of that. You need to make sure whatever you're doing is sustainable. The last set of 4 that we have is continuous attention to technical excellence and good design that will enhance the agility of your system that you're putting in place. Simplicity, the art of minimizing the amount of work not done. Very key. It's not the art of minimizing the amount of work done, but the amount of work not done. How can we make this thing simple? The best architecture, requirements, and design emerge from self-organizing team. Again, we're talking back about the individuals, they're self-organizing, you give them and you trust them to deliver on their job. At intervals, the team reflects on how to become more effective and tunes and adjust to go forward. So I'd like to say to you all, review these principles as a team in your organization, and categorize them as, yes, it's working. No, it's not applicable to us. Or maybe, you need to rethink the scale and the size that you're doing. Discuss this amongst your team and, try and rate yourself. Lastly, agree on the set of things to make things better. Agree on strategic next steps that can make things better for yourself. Very, very important. Okay, so let's talk about, lean agile principles that you need to consider. I'm not going to talk about all of them again. I'm just going to go through a few of them because of time. We're running out of time now. So you take an economic view of things. You apply system thinking. You assume variability and preserve options. And you look at a number of things and you organize yourselves in around the value stream that you're delivering to your customer. So let's take the first one, take an economic view. Like I said, all of them, the 10 of them, I'm not going to talk about all of them. I'm just going to talk about 2 or 3 of them and then on. So this is about, taking an economic view. In a normal waterfall approach, you'll have your requirements gathering, design, implementation, verification, and boom, you've got a product, delivered. In this way, in the lean and agile way, we incrementally deliver value. We incrementally deliver a product to the customer as we go. I mean, this is something that I picked up from the Apple guys. They said Apple employees talk increasingly about what they call deep collaboration or cross or concurrent engineering. What it means is very simple. Products don't get passed from products that that are delivered get passed from team to team. They're not. You don't just deliver it. One time. They are discrete sequential development stages. They aren't discrete sequential development stages. I mean, rather, it is simultaneous and organic. Products get work done in parallel by all the department at once, and boom, you have a product. So whether it's design, hardware, software, whatever it is, endless interactions with individuals, constantly meeting regularly, and then delivering the product. Okay. Yeah, I'm going to run up in just a few minutes. All right, so what I wanted to show you was that comparison, over here. From this perspective, you can see that we're able to deliver value faster to the customer and get feedback, improve the product, and deliver, rather than in a waterfall approach where we can't do that really as swiftly as we can do over here. And on this other side, you can also see that the time to market is faster. The features and when you look at this blue curve over here, you can see that those features that you started with, set of features you started with, customers get used to them, they want more. Customers get used to them. You've got a chance, because you've delivered something to them very early in the day, you've got a chance to start adding those features in and delivering them into the hands of the customer. And then gross margin, which is why you're in business. You start making in money before this waterfall guy gets to start making money. You're already making money. So you always have to look at all of this and trade them off. I'm not going to spend time with that. I wanted to spend really important to look at, to have system thinking behind all the things that you're doing. A system can evolve no faster than the slowest integration point. How you develop and deliver those systems must be a deep consideration for your organization and your team to deliver a proper system. Okay, like I said, I'm not going to go into all of this. I can send the slides so that you can get a sense of what it is that we're doing here, or that we're talking about here when we talk about business agility and a lean mindset. But just to make sure that you understand the concept, it's about plan, do, check, and adjust regularly within different teams, and allowing everybody bring in that feeling into the game, and continuously doing that as you incrementally deliver value to your customer. It's important. The people are important, so it's very important that this industry is about knowledge workers. It's not just about somebody just pushing a button. It's about knowledge workers. They're very qualified. They know what they're doing. So what you need to do as leaders or anybody leading such a team is you must allow knowledge workers manage themselves, make them self-tuning, make them trust them to deliver the work, give them the work, the tasks, give them the storylines and the features you want them to deliver, and track that and get it done with. Okay. I wanted to show a video. I'm not going to do that. But I'm going to pass on and just go towards the end so that I can close. Okay. So in order to achieve business agility, we must increase the ability to deliver innovative products and services to be sure that the enterprise, it's about understanding the problem from the get-go. And you do that by doing discovery, walking to the customer or walking in their shoes, understanding exactly what they need. Once you've done that, you jump into the design stage, do the design the right way, and then start to deliver some value that is sustainable and that you can sustain that delivery. Don't forget, the customer is primary. Customer is the focus point of all of this. The customer is the reason why we're here. They're the ones who can fire everybody. But like I was saying, so this is the design mind thinking, or the design thinking that I wanted us to really see. So yes, you've got a problem statement, you've decided on you've understood what that problem is. you've done a Gemba walk where you've gone into the shoes of the customer and taken a walk around. You've also defined personas, empathy maps, and then you've done a prototype, because now you understand the solution, you know all the features that you're looking for, and you're able to come up with prototypes and story maps and prototypes that can help you deliver the solution. I'm not going to go into personas. I assume that you guys understand what that is. But yeah, these are all the things that are very important for you to have in terms of delivering the solution. So in simply terms, right, you've got to have tool sets. You've got to have a to-do list, which is loosely called your backlogs. What exactly do you want to deliver as in your objective, and then you go into the planning, and then you start building, and then you start that cycle, which is called sprints, that are basically 2 to 4 weeks. Some say 3 weeks. Doesn't really matter. Just choose what you're comfortable with and run with it. And once you start delivering that, you can start releasing the products, testing and releasing the products. So in Agile, testing happens right in there. So that's why it's Agile, because it's built in. Everything happens together before any product is released. Yeah. So this is how it looks in general. And these are some of the tools that can help you with all of these orchestration tools. You've got provisioning tools, infrastructure tools. My colleagues are going to start talking to you about all of that very shortly. In closing, right, it's very, very important as somebody looking after DevOps teams to employ a system that will deliver value the shortest possible time. Flow of customer value. You must understand that. So these are 7 habits. You must ensure that you deliver value to customer. So to do that, use rework, ensure that customer is happy. Gather evidence, gather evidence, meaningful, representative, real-time evidence, experiment and measure whatever it is that you're trying to deliver as value. Manage technical debts, define what is done and what is left to be done, and any debt is a risk. So try and pay it off as quickly as possible. Team autonomy. Make sure your team is responsive, agile, and nimble, and practice quality technical delivery. Then the production first mindset is very important. So these are 7 habits that I've practiced with over time, and I hope that it will help you in looking at this properly. I don't know if there's any questions. Stop here. If there's any question, you can raise up your hand. Any questions? If not, I'm going to hand over to Suleiman, who's going to continue from here. Thank you.
All right, thank you very much for the presentation. It was cut off and right on point. All right, we'll be moving to Suleiman. Here will be taking us through the presentation for the first session before the break. So, Suleiman, if you're there, just unmute so we can roll. Thank you.
Hi, good morning. Oh. Hi, can you hear me?
Yeah, good morning. Yeah, I can hear you loud and clear. Please continue.
Okay. I can go ahead and share my screen, right?
Yes, you can share your screen.
All right.
Thank you.
Can you see my screen?
Yeah, it's clear. Let's go.
Okay. So just a minute. Okay, good morning, guys. So today I'll be talking about Azure for developers. So that's the main topic I'll be speaking on. So if you see Azure for developers, so many things is going to come to our head, into our mind. To some people, they'll be thinking about cloud computing. To some people, they'll be thinking about system somewhere where people are hosting the application. And then to some people, they will be thinking about DevOps and operations. They will be having that in mind. A lot of things usually comes to our mind when we see Azure for developers. And then some people even think about Azure developers is all about developers. But basically, when we talk about Azure for developers, it basically means developers using Azure environment, which is provided by Microsoft to deploy and then to build the application. That's the basic meaning of Azure for developers. And then when we talk about Microsoft services in Azure, we'll be talking about the storage services, we'll talk about the networking, we'll talk about the computing services, and a lot of it. So we'll be talking about the introduction, what is DevOps, what is Azure DevOps, component of Azure DevOps. So let's look at the word of developers. When there is a new application, let's say someone somewhere, a client, come up with an idea that he wants to develop an application or he wants to solve a particular problem. Let's say there is a problem in transportation, there's a problem in health sectors or other sectors, and then somebody just have the idea about the application that, oh, this is what I want to solve. So once that idea dropped in the front of developers, the next thing you see developers do is to come together. So once they come together, they begin to discuss about how to develop the application. And then today, there are ways where developers come up with their decision and conclusion on what they want to do. Like for example, now we have Sdlc. So when we talk about Sdlc, we're talking about software development life cycles, and then there are like 5 steps in Sdlc, which I'm going to just go through because of time. So the first one is requirement gathering. So once there's an idea, the next thing is let's gather requirements. Who and who are meant to use this application? Is it for people under the age of 18 or people on more than 18 or everybody? Is it for a female or for a male? Is it going to be used by students or by any set of people? All those things will be discussed at the first stage. That place, they will come up with the documents, the business documents, and the requirements on what they are going to do. That will be the guide that the developers is going to follow. So after that, they will move to the next stage, which is the design. At the design stage, that's when the developers will think about the code they would want to write, the database they want to use, the architecture they want to follow. They talk about the systems they want to host the application. They talk about CI/CD as well. So all those things have been discussed there, because if that stage is skipped, there will be an issue at the end of the stage. So they have to discuss and plan what they want to do. So, and after that, they will go to the next stage, which is the development. and that's where they will talk about, they'll begin to write the code. They'll begin to write the code. They will push to repository. They will create a database. They will write their functions, and they will do a lot of things. With that, in that stage, they will be developing it module by module, so that they will follow the requirements that is already defined at the beginning of the process. And after that, when that is done, they'll move to the next stage, which is the testing stage. And that's the stage where we have the testers. They will come on board and test the application to be sure that the application is actually doing what it's supposed to do. And after that, we are going to have a QA. QA will come and check if all those functions and the modules are actually working the way they are supposed to do. So that's the development stage. And the next stage is that's the testing stage. And the last stage is the review and the feedback stage. So at this stage, they deploy to the client's environment, and the client is going to check, oh, this and this, I said that I want it here, this and this is fine, but this needs an adjustment. So in that stage, it is possible to go back if there are some things that they need to correct or some things that they need to add to it. So and after that, it can now go finally to the clients and the user. So people can begin to use the application. They can begin to do all sorts of things that they want to do on it. And that's the stage where the solution is being created, and the customer will be happy, and the client as well. So those are the things that developers would be thinking when there is an application to develop. But in the real world, the customers, the clients, they'll be thinking about some other things. So what they'll be thinking about is the next hot thing, how the application is going to be the latest, how it is going to compete with other competitors, how it is going to be used by people. That's what they will be thinking about, because they know that once this application is out, people can interact with it and then use it for whatever thing that they want to do. That's what the real world will be thinking about. And after that, they'll be looking at geo expansion. For example, now, maybe when they are gathering the idea, the application is just meant for a particular location, let's say Nigeria. So when the application is ongoing, they'll be thinking about how to expand the application for other people to use in all over Africa, maybe in US, in UK. They'll be thinking about that. And after that, they'll be thinking about the privacy, security, and the requirements, because people's data are with them. So they need to protect and secure the people's data, so that there will not be anything that will affect people's data. So they'll be thinking about the requirements. They'll be thinking about how to talk to a security agency on how those information can be protected. So these are the things that they will have in mind. And then they'll also be scared about competitors that might want to attack them, maybe by attacking their system to make the system useless or something. They'll be thinking about as well. And after that, they also think about the new features that they are going to add into the application. So if, for example, now, Facebook of 10 years ago, it's not the Facebook that we have now. There are a lot of features that have been added to it. WhatsApp just released new features which make it possible for group video call and group call to happen. So those are new features that people will be thinking, both the clients and the customers that are meant to use the application. So after that, they will also think about the money, the money that they are going to use in executing all those tasks, like the server, provision of server, provision of awareness. All those things is about money, and they will be looking for investors. They will be looking for people to help them so that they can show the application to the real world, and that's what they will be thinking. And after that, it is now time to go to the market. At this stage, this is where we have the marketers, where they now market the applications. We have jingles, we have Facebook ad, we have Twitter ad, YouTube ad. So they'll be thinking about how to make this application to the real users. So that's what they'll be thinking. So, and after that, when the application is already done and they're already thinking about all those things, there is no understanding between the developers and the operations, because they are not working together. The operations team, they are working on their own, where the dev team is already working on their own. So by the time they want to come together, there will be lack of understanding and there will be confusion, which will result in disaster. There's a particular scenario whereby a developer finished developing an application, and then the infrastructure team, they have already provided the server is going to use. But at the time it gets to the point of deploying to the server, they notice that the version provided for the server is lower than what the developers have already completed. There's an issue there because the client has already invested a lot of money in it. So this now cause issues for the developer. They now have to downgrade the application, rewrite some of the function so that they can work with the server provided. And that's the traditional way of developing and operating during those times. And it always resulted in a disaster. So those problems is that the developer will have to rewrite the code. The developer will waste a lot of times. The developer will waste a lot of energy because the developer is actually not understanding what the operation are doing, because they are not working together. There's no synergy between them. So those are problems that we have before now. But now that we have DevOps, it has actually solved most of those issues. So what is DevOps? So when we talk about DevOps, so we are talking about practice intended to reduce time between committing a change in system and the change being placed into normal production while ensuring high quality. So DevOps comes in place so as to solve all these issues. Now, the DevOps teams, the operation team, and the development team will need to work hand in hand. They'll be working together. The operation team will understand what the development team is doing, and then the development team is also, they also understand what the operation team as well as doing. And then some of the things that is being done for the development team is a plan, which I've explained in some slides back, that they plan, that's where they plan or what they want to do on the people that will use, on how they will use it. Is it mobile? Is it web? That's where they will plan all those things. And they will now move to code. That's where they will now write all their code, put all the logics in place. And after that, they build that system and deploy and after they deploy into a testing environment, they now test. There is QA that is always available to test the application. So, and after that, once everything has been satisfied that it is okay, it is now moved to the operation team. That's where they will talk about the release, the version control, what they need to do, which features is meant to go, which features are they meant to delay. So, and after that, we now move to deploy. We have testing environments and we have production environment. Testing environment and development environment is for the developers. They can do anything on it just to make the application work. And after they have done all those things, the development environment and the testing environment must be the same with the production environment so that there won't be any issue during the final release. So the operation team will deploy and then operate. If there's any configuration that they need to do, they do that. Any setup, any email they need to configure, they do all that. And once they are done with that, they send email to the necessary people that we are done with this. The application is live and running, is up and running. You can check. So, but their work did not stop there. They need to continue to monitor because there are things that can happen to an application after it has been deployed. It can be traffic issue, it can be database issue, it can be environment issue, it can be anything. So they need to monitor. So once they monitor and there's any issue, they relate back to the development team that this and this is happened. How can we scale this application? How can we do this? How can we do that? So which means there is connection between the development team and the operation team. Okay, so what is DevOps? So this is the union of people, process, products that enables continuous delivery of end users. In all applications, there is continuous integration, there is continuous delivery, and there is continuous development. So once an application has been developed and has gone live, it does not end there. There will still be some additions, some new features that needs to be added to the application. With that, the developers need to be very careful so that they will not cause issues with the application that's already been used. So that is where continuous integration comes in. So once they are having new changes, new tasks, they will add it, and then after that, they will need to go back and test it before they deploy to the production. Because if they did not follow that process, there could be an issue. So that's the reason why continuous integration, continuous delivery, and continuous development is very key in the DevOps environment. So let me quickly go through these. Okay, we have the build and test, we have the develop, we have the plan and track, we have the monitor and learn, and we have the operate. These are the things I've already explained in the previous slide. Okay, let me move to the next slide. Okay, so let's talk about stages, the stages of conversation in DevOps. We have 3 sets of people involved in DevOps. We have the people, we have the process, and we have the products. So let me talk about the people. So the people are basically those that are going to develop the application. So they are the one that's going to make the process a reality and achievable. There are people that work day and night to deliver the products. So we have different people under this. So we have the DevOps, we have the Devops Evangelist. So they are the one that knows everything about the DevOps. They have the idea about the DevOps, they understand the process, they understand the products, they understand everything. So they are the one that is going to guide the process. And then after that, we also have the developers. So developers, they are the one that is going to develop the application. They will develop the application, they will make sure all the logics are running, they will make sure all the sprints are being attended to, they will do all those things in programming or in coding. So, and then after that, we have the release manager. So the release manager, there are a set of people that is going to release the application once it is done. So the release, if you notice, Twitter, maybe like 2 months or 3 weeks, frequently you'll be seeing updates your application. Even Facebook as well updates your application. What they are trying to say is there's a new release which they want you to see because there's a new features. Fine, it's not compulsory, it is a new features. It might be the security that they work on, or maybe they just work on the database, or they just work on the system itself, and then they release it so that you can have the updated application running. They do all those things sometimes because of even hackers. If they notice that the security of the application is not that strong, they look at how they can improve the security and then release new batch. So the work of that is release manager. Even if you check your phone, you will see OS 12.1 version, 10.1 version, Android 5.0 version. They are releasing new updates, and that's the work of release manager. They are the one that's going to version all those things. So in case what they release is not okay, they can easily fall back to the previous version. But if they don't put all those versioning on it, there will be issue, because to roll back an application to the previous version without a well-documented process will cause an issue. So after we have the release manager, we have the automation architect. So when we talk about those people, things are not done manually again. Before, everything is manually. You set up your server manually. You will set up server manually, your database manually, you deploy manually. But now things are changing. Things have changed. So we have infrastructure as a code. We have SaaS, which is software as a service. We have platform as a service, and we have infrastructure as a service. So it is the work of the automation architect to make all these things fine. So they are the one that will run all those automation so that there will be downtime. Before, when we are doing manually, there is always downtime because they will need to stop the service that is running, and after a while they will deploy, and after that they will now start it all over again. There are time that those applications will have to stop. Sometimes 5 minutes, even to some companies, you will hear we want to upgrade our system from 1 o'clock a.m. to 3 a.m. So all those things are not like that again. With the help of automation, you will know that things have changed. You will know that there's a new release that they deploy. So that's the work of the automation architects. So let's talk about tester. It is compulsory for any application to have a tester. They are the one that test the application. The developers will do unit testing, and after that move it to the testers. They are the one that will do the real testing. They will do the performance testing. They will do load balancing testings. They will do different testing to be sure that there is no bugs or issues with the application. There is a particular approach that is being used today, which is TDD. That's testing driven development, which means before a developer can even think of starting coding, the testers will come up with their test that this button on click of it should save into a database and should return this. So that's what the developer is going to follow. Once the developer follows that, there will not be issue with the testing because the developer is developing the concepts based on the testing principle that has been set aligned for him. So that's the benefit of TDD. And we still have other principles of the developing, which time will not permit us to talk about. So now we now have the QA. The QA is quality assurance engineer. So they are the QA. What the QA does is that fine, you are done with the application, but the quality of the application, is it there? Does it solve the issue, the problem the client wanted to solve? Can we take this thing to the public? Will people be able to use the application and enjoy it? That's the work of the quality assurance. They make sure they check all the necessary things. They check the UI and the US so that there won't be any issue with the users. So that's the work of quality assurance. So the next one that we have is the security engineer. So the security engineers, they are the one that look at the security of the application. They make sure that the application cannot be attacked from people outside the system. They make sure that DDoS does not affect the application. They ensure that the data of the customer are secured. So that's the work of the security engineer. And we have the utility player. So the work of the utility player is when you have a system, let's say you have your in-house server, for example now, is the utility player that will ensure that there is 24 hours light, there is the AC, there is the place is clean, people that are not meant to be there are not going in. All these things, they are the work of the utility manager. They keep it, they keep it daily, they make the place secured so that people that are not supposed to be there are not there. Light is there 24 hours. There's AC, there is no socket is faulty. So those are the work of the utility player. So after that, we can talk about the process. So when we talk about the process, so by process, we mean the workflow of what is the workflow of what is meant to be done, like the guideline of how an application is going to be used. Before, we have waterfall. That is what we have, and that is what people are using. But it caused mostly it has a lot of issues, because by the time a developer finished developing the application, they notice that what they are supposed to do is not what they are, is not what they have done. With that, they will need to start the application again. That's one. Also, now we have CI/CD in place. CI/CD means your application has to pass through a particular process before it can get to the final users. If it fails any of those processes, like build, tests, there will be, if it fails any of those processes, that means it will not go to the final users. That is why we have the CI/CD. I'll still talk more about it. I've talked about in the previous slide, but I'll still talk more about it. There is a particular scenario whereby a developer finished developing an application and it deploy the application to the production, and people are using the application. And then after a while, like a week, the developer noticed that a particular check is supposed to take care of in the application, which it did not. So he now quickly go back to the application and fix that and deploy. So after the deployment, there was a downtime. There was an issue. All those things that are working before are not working again, because the developer does not follow the process. The reason is because the developer did not follow the process. That is why we have that issue. But with the right process, the developer is not the one to deploy. So if there's any changes, it has to pass through those steps before it gets to the final output, which will remove any issues. So that's the reason why we have that process. So I'll quickly talk about I will talk about an Agile methodology. Let me quickly talk about the Agile methodology. So Agile methodology is process whereby we develop application bit by bit. That's the process, bit by bit. So once we finish a particular module, other people involved need to test, the client needs to check, and once that one is fine, you can move that and go to the next one. So it saves times. That's a particular process. The CI/CD I explained before as well is continuous integration. So under process, we have some basic steps there, which is continuous integration, continuous testing, continuous delivery, continuous planning. So those are process. So once you have worked on any particular application, you need to follow those process. So continuous integration is when there is a new features that you want to add, the developer is going to work on that and push to the repository. And then we have continuous testing. That's testing the application every time there's any changes. So we now have continuous monitoring and feedback. So if there's any issues or any problem, you have to come back with the feedback. It is continuous. Continuous delivery, continuous deployment, and continuous planning. The planning is we want to add new features to it. What and what are we going to add? That's the process. So let us move to the product. The product is where we now have the final product. The application has been deployed, but we should have it in our mind that no application is 100% completed. No application is 100% completed, because there will always be changes that we need developers to come and look into. There will always be new features. There will always be new security, they want to increase, and all sorts of things. That's the reason why we need to go back to the first stage. So having talked about that, so let's move to the next one, which is benefits of DevOps. So for benefits of DevOps, so we have the development frequency. You deploy regularly because there are changes. There are small changes that you need to deploy, and you have to follow all those processes. If you don't follow the process, there will be an issue. Faster time to market. The reason why it is faster to market is you can finish a particular module which is working. Let's say a particular website or application that lists out list of books, for example. Now, you don't need to finish all the application by making an admin to be able to add books or delete books. You don't really need all those things. You can just start from the user. What and what do the user need? They want to be able to view books. Then you go ahead with that and deploy. You have got to the market. Then later you cannot be working at the admin part where they can add more books, where they can delete, where they can add more authors. But before, without the DevOps, it will take time because they will make sure they finish all the application from the beginning to the end before they go to the market. So the next one is lower change failure rates. There are always failure rates. There are changes. So once there is changes, there is tendency that there is failure. But if all the process are being followed, you test, you deploy, you do QA, if all those things are done, there is chances that there will be no failure rates or even very small rates. But if DevOps is not considered, anybody, any developer can just change anything and just deploy and even go ahead without even testing it. So there is always an issue. There have been a situation whereby a developer resigned from a particular company and then he just deployed the wrong version because they are not following the process there. They have issues. It was later that they now find out that what the guy deployed was old version. So and it caused failure. But if the process is there, the developer cannot move the application to the production. It has to go to the next stage, which developer is not in control of. They just need to just understand themselves. So faster lead time for changes. So it is possible to do changes in time without any problem. Increase revenue. The reason why it increases revenue is because when there is minimal failure rate, it will surely increase the revenue because the company will not just be spending and spending. And then people will have trust on the application. Because if you see an application that is very fast and it has never gone down before, people will continue to visit the application. But if they come there today, it is down. They come there tomorrow, there's an issue. They come there the next day, there's a bug. People will be leaving that application and they will be losing revenue. So the next one is faster mean time to recover. There are some services on Azure or in cloud that make it possible for your application to scale up or scale down when there is an issue, or even move it to a separate server. But if you are not following the DevOps and you are not using that cloud, that means you will need someone at the office to be changing all those things, to be buying all the hardware, all the sockets, and all these things. But if you are following the right process using the CI/CD and the cloud, That means if there's any issue with the traffic, it is possible for your application to just scale up. And then once the traffic is, once the traffic reduced, then they can scale down again. So that's the function of elasticity in DevOps and cloud. So let's now talk about Azure. So we have talked about DevOps. So let's talk about Azure. When we see an Azure is a cloud computing platform, an online portal to access and manage resources provided. For a layman, let's see an Azure as someone else's computer. So there's someone that has a computer that set up that computer, that set up the VM, that set up the servers, the instance, which you are connecting to. So that is Azure. It's not like there's somewhere in the cloud where we have all this information. No, there is nothing in the cloud. It is someone else's computer that we're having all those information. But the reason why we are calling it cloud is because you as a developer or a DevOps engineer, even the infrastructure, you don't need to bother yourself with the infrastructure. You don't need to bother yourself with the server. You don't need to bother yourself with electricity, because someone somewhere is actually doing that for you. So let's see it as a Facebook, for example. Now, in a Facebook, I have my own platform where I can go add my name, change my password, change my image, upload posts, and someone else too also has his own where he can do all those things. So that is cloud. So I can have all my application in a particular place somewhere where another people cannot interfere with it. It is secured. Nobody is going there to touch your application. Even those people that is managing it cannot do anything on your application or your resources because it is very secure. And when we are talking about Azure, we'll be talking about, okay, Azure is just a company that provides cloud computing platform. We have many of them, but now we just focus on Azure. And then there are different resources on Azure. We have the storage, which is database. We have the blob, where you can put your pictures. We have the CDN, where you can put some particular information for particular people in a particular location. We have that. We have app services. We have functions. We have serverless. We have stable storage. We have a lot of resources which you can use. So with that, you don't need to bother yourself about having a dedicated room in your office where you now put all those hardware that you'll not be able to sleep, because if the light goes off now, for example, in Nigeria, where sometimes we now have lights for 10 hours, even more, you will now be burning fuel, you'll be wasting your time. With that, you don't need all that. Azure is secured, and it's 99.9 secured. So that is an Azure. So before I move to the next slide, let me talk about PaaS, which is platform as a service, HaaS, infrastructure as a service, and software as a service, SaaS. So when we talk about the HaaS, IaaS, that's infrastructure as a service, which means you need to set up your VM, configure your VM the way you want it to be. You need to do most of your setup yourself. You put VM, you set up your database, the one we are doing at the premise today. But the only thing there is you are not the owner of the of the infrastructure. The servers is not your own. The physical hardware is not your own. You are just in control of a particular portion which is given to you. That is the one we call infrastructure as a service. So the next one is software platform as a service. Platform as a service is you don't need to bother yourself about setup. You don't need to bother yourself about the infrastructure. You don't need to disturb yourself about any configuration, any network. You don't need that. Just bring your code, drop it there. Once you drop it there, it will be up and running. The only thing you need is your code. That's all. All the remaining things, going down, going up, they will take care of that for you. Unlike the infrastructure where you have to where you have to monitor all those things yourself. So the reason why the first one is there is because of a big company that might want to have control over everything. They want to have their own setup. They want to have their own configuration. They want to have their own files. That is why we have the infrastructure as a service. So the last one is platform as a service. Let us see the 365 that we are using.
All right, Mr. Sulaiman, please let break starts now. We'll get back in 12:20, please.
All right.
All right, we'll continue next from there. Attendees are allowed to go to have a coffee break, and we'll resume back here by 12:20 exactly. So let's take our time. All right, team. Thanks for taking a break. We are good here. So, Mr. Sulaiman, you could, if you're up, you could start. Then, yeah.
Can you hear me?
Yeah, loud and clear.
Okay.
Can you share your screen, please?
Yeah, I'll share my screen. Okay. Okay. Can you see my screen?
Yes, it's clear.
Okay. So this is where we stop, so we can move to the next slide. So we already talked about past, SaaS, and has. So we talked about that. So we move to the next slide. Okay, so Azure data center and region. So when we talk about Azure data center and region, so we have region is a physical place where we have our data centers, where we have the physical device, where we have our servers, we have the computers, we have the building that is powering all our resources, all the resources and application. That is what we call the data centers and the regions. There are more than 150 data centers in Azure, and there are regions as well. So we have like Azure region, we have West US, we have North Europe, we have North Central US, we have South Central US, we have a lot of it. It's 61. So that's the region. So let's see region as, let's say Africa. Let's say region as an Africa. Then data center, let's say Nigeria. That's where we have the physical server, those servers that we have in-house today, that we are using on-prem, those ones. So those are the one we call the data centers. And we have over 160 or over 150 data centers. And then the distance, there are distance between the regions. So the distance is like 300 miles or 480 kilometers from each regions. So, and it is located around the world in a strategic places that is going to meet the customer demand. So the way it works is this. Let's say we have one region in South Africa. Okay, let's say we have one data center in South Africa, for example. I that I'm in Nigeria, it is very easier for me to get to South Africa than getting to maybe Australia. So anytime I want to set up any of my resources and I'm targeting Nigeria, for an example, it is better I pick South Africa as my data center. If I pick Australia, for example now, the latency is going to be higher. Let's say we have 1 minute to load an application in South Africa when I'm calling from Nigeria. It might take 2 minutes or 1 minute 30 seconds if I'm calling from Australia, because South Africa is nearer to my place. And that's the reason why it is always advisable that if you know your target audience, try to locate the server where they are so that it will be easy for them to access. But in a situation whereby you don't even know where your where users are, let's say they are all over the country, it is possible you sign an agreement with Azure that you'll be able to put your application, they will able to replicate your instance on all the different data centers. So if somebody is calling from Australia, the person will hit Australia data center, not South Africa. If I am calling from Nigeria, I will hit South Africa, which is nearer to me. Let's take Netflix as an example, because Netflix is also using one of these cloud computing. I want to watch film from Nigeria. I'm going to connect to the nearest data center. Somebody from US will connect we connect to nearest data center to him. And that's the reason why we see that Netflix is very fast when you are watching film with it. So that's basically about data centers and then regions. What is Azure Devops? So Azure Devops is a Microsoft product that produces version control, reporting, requirement management, product management, automated builds, testing, release management capabilities. It covers the entire application life cycles and enable DevOps capabilities. So all these things that I've explained in my previous slides, like the culture, the process, the CI/CD, deployment, build, testing, all these things are possible on Azure DevOps. That is the reason why we have Azure DevOps. Azure have a particular resources for it. It's a product. So that's the reason why we have the Azure DevOps. And Azure make it in such a way that you can have all your configurations, all your pipeline, all your workflow on their platform without you thinking about how to do this thing manually. So with that, it is very easy to test, to do automated builds, to release management. So for example, now if you push your application to GitHub, for example, now the Azure DevOps will pick the application, run some function on it. If it is running fine, then deploy to your environment. Azure, for example, it will deploy it. With that, all the flows, all the workflows is already been taken care of. And that's the reason why we have Azure. So it gives room for teams to plan their work and collaborate in their code development and also build and deploy the applications. So that's basic of Azure DevOps. So let's look at the component of Azure DevOps. So we have the Azure Board. So that's a work tracking system with Kanban board, dashboard, and reporting. Let's say I have a task, for example, now, and the task is meant to be delivered in 5 hours. So once we have all those tasks on the Azure board, it will be easier for anybody to just go there and track my progress. They will know when I start the task and when I'm supposed to finish it. And they will know if I've already finished it or not. So Azure Board makes those things very easier. I can assign tasks to myself. I can assign tasks to anybody. And with that, we can comment and collaborate on it. That's the function of Azure Board. It helps in planning, tracking, and working with work items across teams. So Azure Pipeline is a CI/CD and testing and development system that can connect to any Git repository. I've talked about continuous integration and continuous delivery, which means there are new tasks that are meant to work on. They're working on it and pushing to repository, that's CI. So the CI/CD is deploying into the server that people can connect to. That's the CD. With that, you can test and deploy the system into any Git repository. We have Git, we have Bitbucket, we have GitLab. Azure Pipeline can work with any of those repositories. The main reason why it is necessary we put our code inside the repository is because, one, for developers to be able to review, collaborate on it, check your code, see if it is fine. And it is mainly for security purpose. For example, now anything can happen to my system where I'm developing my application. So if anything happens to it, and let's say it gets lost, how do I get my code back? That's the work of the Git repository. So with that, as you are working daily or even hours, you are pushing your code. So if anything happens to your system, it will be very easy for you to go and pick your code there. It's only system that you don't need. You can pick other system and get your code back. So it is very safe. And fine, it is public and it is private. So if you subscribe to the private, nobody can see your code except the people that you invite to come and see your code. But if it is public, that means anybody can come there and put a comment and do anything that they want to do. They can steal your code. They can use your code. They can adapt your code if it is public. So that's the function of Git repository. So Azure also have Azure Repos. That's the repository for Azure Repos. So it's a cloud-hosted private Git repository service where you can put your code for collaboration, for reviews, for communication with other developers, and for proper monitoring. It is possible for a developer to say he has been working all day. It is possible. But how are you going to know if truly the developer is working all day? Is the use? That's another reason why Git repository is necessary. So at the end of the day, your developer push their code to the repository. You as an admin can go there and see what it has been done. With that, it is difficult for developers to lie, because when you have your code there, you can see what you have done. You can see the functions you have implemented. So Azure has its own, which is Azure Repository. So for managing your source code repository. So I said we have different repository. We have GitLab, we have Git, we have Azure Repos, we have Bitbucket. So what will happen? Let's say I'm using GitLab, for example, now, and I want to change my environment. Is it possible for me to change my repos? Yes. Azure Repos, you can bring a code from GitHub and push it inside your repository. The company might decide that, oh, we are not using Git again because of this and this. We want to be using Azure. It is possible you pull your code from Azure and push it to Azure repository without any issue. Plan. So a solution for test and capturing data about defects. So I said that the testing, so if there's any test, the test plan can capture any issues. It can run some tests and tell you if there's any problem with your code or not. So Azure Artifact. So when we talk about the Azure Artifact. So that's hosting facility for moving npm and NuGet packages. For example, there are some particular modules that you could have worked on. For example, now let me use a banking system. For example, now let's say a company want to connect to a banking BVN service. It will take time for the developers to be writing the integration, writing the code. It might be very time consuming and very difficult. But with Artifact, they can develop a working application modules which they can push to the artifacts that anybody can pull. Once you pull, you don't need to do any code. Just run it and provide the necessary information you are supposed to provide. That's all, and you are fine. So that's Azure Artifact. So it is used to manage your packages. So the DevOps, let's look at the DevOps, the application insights. Let's look at that. So it is possible that you have an application and there's a particular information, maybe the server is down or your application is not doing well, it is slow around some particular time because there is high traffic, or something has happening. With application insights, you can actually see the issue with your application. Maybe there is issue with the database, maybe there is the application is not running very fast, maybe there is leakages in your application, maybe the objects are not well closed. It is possible to see all those things in the application insights. Also, on the infrastructure you are using and the network, you can see all those things in application insights. So I've talked about Azure Artifact, I've talked about Azure Board, I've talked about Azure DevOps, I've talked about Azure Dev Test Lab. So Azure Monitor, it is used to monitor your application. Let's say you have an application, for example, a banking application. So people visit your application, let's say around 8 o'clock in the morning till 12 noon in the noon. So it is possible you monitor those traffic for you to decide what next you want to do on your application. That means you can spin up more instances of servers to be running at that 8 o'clock to 12 noon, so that your application will not be slow. Then by the time you have by anything after 12 noon, then you can now reduce those instances, so that at least, because you don't have much traffic there, so you can reduce it, and then the next day as well you will spin more server. That is being done automatically. You don't need to be doing it manually. It is automatically once you have all the configuration and setup in place. So I've talked about Azure pipelines, I've talked about Azure Repos, I've talked about Azure Pipe Test Plan. So GitHub action for Azure. So GitHub, Azure has acquired GitHub. So which means it is very easier now to use GitHub on Azure. So GitHub as well is used to build, test, deploy your code into the environment, and then to save your code. The same way we have Azure Repos. That's why we have the GitHub as well. So let's talk about the best compute for your solutions. There are a lot of compute resources on Azure that you can actually use. We have the Azure API apps, which is used to build and consume cloud APIs. There is app services. With app services, you just take your code, deploy your code without disturbing yourself about any much setup or configuration. So once you deploy your application on app services, within 1 minute, even 30 seconds, your application is up and running. Azure Cycle Cloud, so it is used to manage and operate to optimize big compute clusters. Let's say you have a very big application that is having a lot of traffic. So you can actually use that to perform scalability on your application, which means when there's an high traffic, you increase the instance, and when there is low, you reduce the instance of the server. So we have Azure dedicated host, we have Azure functions. Okay, let me quickly talk about Azure functions. We have serverless. When we talk about serverless, people have been hearing about serverless. Serverless actually means you don't have to do anything concerning the server. You don't worry yourself about the server. And then in such a scenario, Azure functions you only pay for Azure, you only pay on Azure function when it is used. Unlike app services that when you deploy, from that moment they will be charging you. But for Azure functions, you are only paid for only when they eat your service. That's when you are going to pay. That's the only thing about that. So with that, you can save more money. The company can save more money because it is not all the time that the application is being used. For like in the middle of the night, for example, now they might not use the application for a while. With that, you'll be saving for the company. So Azure Kubernetes cluster. So let's talk about Azure Kubernetes cluster. So for Azure Kubernetes cluster, there are so many scenarios whereby developers will finish developing an application, and by the time to get to the server, they'll face issue. The issue they will face is, this thing is running on my system. Why is it not running on the environment? We have a lot of that issues. So Azure now come up with a solution with that, which is Docker. With Docker, it means you can build your application with all the necessary configuration, with all the necessary packages. And when you deploy it, your application on the production will be using your own version and your own package on your system. This will not use what we have on that system. It's like a VM virtualization, but it's different from virtualization. Virtualization, VM has to do with the system. Whatever operating system we have on the system is what VM will be using. But for Docker, it will use the one on your system. That's where it is package your application with. And once you drop it on that environment, it will be using your own packages, not the one on the systems. So that's where we now have Azure Kubernetes. So it is possible to have 10 different corpus, Docker. You have BVM validation as an application. You have CRM as an application. You have banking. You have different applications like 10. It will be very difficult to be checking it one by one that, oh, is this fine? The second one, is this fine? There are a lot of it. So Azure Kubernetes manage all those Dockers, all those nodes. With that, you can have a single interface where you can manage all of your Docker application. So that's the function of Azure Kubernetes. So we have Azure Quantum Preview, we have Azure Spring Cloud, we have Virtual Desktop. The Virtual Desktop is just your own desktop where you can actually remote in. There you can install anything. You can put your SQL. You can set up IIS. You can set up any environment on Azure Virtual Desktop. So Azure VM solution, which means you can run your VM workload on Azure, and that's where we have the IaaS, infrastructure as a service. So we have batch, we have cloud services, we have containers. The container I was talking about is the Docker. I've already explained that before, which you run container on Azure without managing the server. I've talked about that. So Linux virtual machine, fine. Azure is a window machine, but you can still run your Linux on it using Linux virtual machine. Also, we have service fabric, which is used for microservices. So now people are using microservices a lot. The function of microservice is that if there's any issue with a particular application, before now, if there is an issue with a banking solution, for example, now all the application is going to go down. That means those people that want to make transaction will not be able to do transaction. Those people that want to register for a new account, they will not be able to do that. Those people that want to do a bank statement, they will not be able to do that. But now, with microservices, you develop those applications independently. That means you have an application for creating an account, you have an application for bank statement, you have an application for transaction. So if anything's happened in transaction, it will not affect bank statements. People that want to do bank statement can still go ahead and do their normal bank statement. People that want to create an account can still go ahead and do they can still open their accounts because it is independently. It's not relying on one another. So that's the function of service fabric. So we have SQL Server, virtual machine. We have static web app. So static web app is just mainly for application that is just read alone. So it's not connected to any database. So that's static web apps. So for SQL Server virtual machine, it's just your SQL Server on the cloud. So we have virtual machine, skill setup, we have web app, and we have window virtual machine. So you can pick any of these based on your requirements, based on what you want to do. Let's say you just want to have an application, a website that is not interactive, that is not writable, it's just for read alone. You can choose static web apps for it. With that, you won't pay more for it. Let's say you want an application that can connect to database and you can set up within a minute. You can use app service for that. Let's say you are trying to save costs. Let's say you are trying to save costs, for example, you can use Azure function. Let's say you are having issues with deploying your application on production and you're having issues. You can use Azure containers. There was a time that there are two developers, they are working on a particular application, different application on the same server. So the first one, the main application the application it has different function, but one of it is they are uploading an Excel file. So the first developer used a particular version of Excel to code his own application. The other one used a particular function, and when they deploy, they're having issues. Only one is working because only one of that version is running on that system. So they were having issues. Though the reason why they were able to solve this using containers, which means the first one containerized his own application using his own version and packages and deploy. The second one also did that, and they are both fine. So you can choose any of the application, any of the service that you feel that is okay for you. So the next slide is why Azure best for developers. So delegate service maintainer to Azure. Focus on creating your API. So developers, they don't disturb themselves on the maintenance. They don't disturb themselves is setting up the infrastructure. They don't care about the lights, the AC. They just focus on creating their API. And once they are done, they deploy. So that's the reason why Azure is okay. So the next one is develop, deploy, and operate. You don't need to care about how the server is. You don't need to care about what is in the server, what is the version or something. Just focus on your API and then use containerization and you deploy your application. Even the CI/CD will do that for you, and then you are fine. So choose. So you can as well choose the best services that is okay for you. But the advantage of Azure and cloud computing is that you pay less. The cost of setting up a server these days is very high. And then you continue to maintain it. You pay for lights, you pay for AC, you pay for security man, you pay for different expenses. But with Azure, you can choose best services that you want in a minimal with minimal fee. So you can choose your pricing model. You can put a condition that once you have exceed $10, for example, now it should notify you or stop so that you will not exceed the amount that you plan for in a particular month. So that reason why choosing the best services in Azure is just the best compared to premise. And then the charges on Azure is very small, very small. So maintain and support. So just to maintain and support your solution. If you don't care about the server, you don't care about what's going to happen, you don't care about burglars, you don't care about all those things. Because if anything happens to your application where it is, it will automatically take you to another server. And that is what we call fault tolerance. Fault tolerance means if there is any issue, it should be able to come up quickly for you and give you another solution. Unlike premise own, if there is no light, that means everything is down, everything is having a problem. If there is a burglar, that means there is issues. Or people will not be able to get into your application again. But with Azure, if there's anything, if anything bad goes, maybe the climate change or anything, it will spin another server for you in a different region, and then you'll be fine. You will not know, except they send an email to you that this has happened and we are fine. So that's for that. And then the last one is integrate with micro ecosystem, dynamic, Microsoft 365 and others. So you can integrate with anything in your application. If you are developing an application and you are collecting you are collecting pictures from people, you can use Blob. You can connect to Blob and you'll be fine. They will take care of your images. They will provide your images for you in a fast, very fast. They will give it to you when you call it. Unlike if you are saving your images in your application, it will increase the latency on your application. And then if there is any downtime or any traffic, there is load balancing that will help you to move all those resources into the necessary place. So let's quickly go about this, we have, okay, let's go about this. We have the premise. So for the premise, we have customers, we have where we have the application, you have data, runtime, middleware, you have OS, the servers, the storage, the network, everything will be in your office. Everything will be in your office, and you have to maintain it. You are the one that will manage it. You have to be thinking about everything, and there is cost attached to all those things, because maintaining it, you have a security, you have a light, you have AC, you have everything. So that means you have to manage it yourself. But at the next side, we now have SaaS on Azure IaaS. So for the customers, what you are going to just do is just to partner manage. So what you are going to do is just your application, your data, runtime, middleware, and OS. That's just those things you are going to do there. But for the infrastructure managed by Azure will take care of the networking, the storage, the servers, and the virtualization. And then the next one is PaaS. So for platform as a service, what you just care about is your application and the data. Just finish coding, take your application there and your data. So Azure will be the one that will look at the runtime, the middleware, the OS, the virtualization, the servers, the storage, and the networking. So they're the one that is going to be burdening themselves over that. So let's go to the next slide. Okay. So for the next slide, we have the app configuration, where we configure our application, where we set up the domain, where we set up the domain, the SSL, and all those necessary things. Where we have the subdomain is where we have the app configuration. And then the next one is Azure Data Studio, Azure Dev Place, Azure Devops, Azure Dev Test Lab, Azure Lab Services, Pipeline, Azure GitHub, Visual Studio. So Visual Studio is just an IDE where you can write your code. Visual Studio, you can write any of your code in it, maybe C#, maybe JavaScript, HTML. You can write any of your code in Visual Studio. Also, we have Visual Studio Code, which is very light, and you can also do all those things on Visual Studio Code as well. So we have the API management, we have Azure API for FHIR, and we have the event grid as well. So event grid is also useful when you want to be notifying people. Let's say you have a blog, for example, now, and every time there's a new upload to your blog, you want to notify your people that my subscribers, there is a new post which you need to read. So you can use Azure event grid. So once you just have a new post, that means it will automatically get all your subscribers and then notify them about the new post. So that's a function of event grid. So we have Logic App as well, which also work with serverless, and we have the last one, okay, the boss as well. So for the database, we have different database. We have Azure API for FHIR. We have the cache. So the reason why we have cache is just to reduce the loading time. Let's say a particular application that people are visiting every time, and the content is not changing. So you don't need to even go through loading the application from beginning again with cache. That means it will be very faster. It will reduce the loading time. That's the function of Azure Cache. And as we have Azure Cosmos DB is for NoSQL. We have SQL database we have NoSQL database. So we have structured and we have unstructured database with semi-structured database. So this Azure Cosmos DB is used for NoSQL, which means unstructured database. Example of NoSQL data is, for example, now we don't know what we are expecting from the customers, from our users. They can just post anything, they can post image, they can put their CV, for example, now. So we don't know how their CV is going to look at. So if you use Azure NoSQL, that means it will be able to capture that CV based on how they have defined it. So it does not have to conform with any any guide or any way. So that's what we mean by NoSQL database. So we have Azure database for MariaDB. We have Azure database for MySQL. They are all database which we use to keep data. We have Azure for Postgres SQL. We have migration services. We have Apache. We have SQL. We have SQL database. We have Edge. We have managed instance. We have table storage. So table storage and Azure Cosmos DB, they are no SQL, but Azure SQL database, Azure database for MySQL, they are structured database. Azure Progress as well is a structured database. So Redis as well for cache is no SQL database. The next one we will be looking at is management and governance. So we have talked about application insights. We have talked about ARM templates. So let me talk about the ARM templates. Let's say you have 10 servers that you want to configure. If you are doing it one by one, that means it will take, if you are using 10 minutes to configure one, that means you use 10 times 10. That's 100 minutes for the 10 servers. But for ARM, you just configure one into a file. So once you generate that file, you can run that file and it will create the sample, the template for the other ones. That means the ARM is just a template that will create other servers for you without doing it manually, and it will save time. That's the function of Azure ARM templates. We have automation, we have Azure Advisor, we have the backup. It's used to back your data, and then there is policy around that. We have 90 days, we have 3 months policy as well. We have the code, we have the hot. So the one that you're actually getting regularly is the hot, because it is every time you will be loading it, like image on the website. It is every time, but there are some documents that you don't even need in 2 to 3 years. So those ones also, it has their own different policy. So we have Azure Blueprint, we have Azure Cloud Shell, Lighthouse. So there are a lot of it, but because of time, I'm just picking it. So we have Azure Log. The log is just to know what is happening, because you are not there, and anytime they access your database, for example, now it will log and tell you what and what happened. So even if there is any issue, the Azure log will log it, and then you can come back to it and see what has happened. So that's the log analytics. We have cost management and billing. That is just used to budget for your resources. Oh, in the next 1 month, how much will I incur if I continue this way? In the next 3 months, how much will I incur? With that, you can plan ahead. And then Azure Site Recovery. If there is anything that happened to your application, the Azure Site Recovery will get it up and running, either by moving it to a different region, or by taking it to a different server, or by spinning up a new instance. It will do that for you. And then for Azure, and then for Azure Traffic Manager as well, it is basically used to just manage your traffic, to know how you are doing in a particular time. So the next one is integrate with Microsoft's ecosystem. So by looking at that, we are talking about Azure AD identity, integration with Microsoft 365 3D, Teams and Novice application, make data actionable, enable a low-code power platform. So you can integrate with all this, and it will reduce your workflow and your process. Let's say, for example, now you want to develop a chatting application for your work office, for example. Now you can just leverage on Teams and Office application. So you don't need to just waste your time or use a lot of resources on that, because we already have that. If somebody already have that, you don't need to bother yourself. Just pick it up and just use it. So you can just recycle the rule. So that's for that. And then for Azure Identity, it's mainly to know the people that log into the system, to have information about the people using your services. It can be useful for the emails, it can be useful for companies, and then different things as well. So list of best of practices. We have infrastructure as a code, which infrastructure as a code, I've not explained that, so let me quickly explain that. So when we talk about infrastructure as a code, it means the act of eliminating manual process. So if you don't want to use manual process, you can develop your instance using code. You can develop your infrastructure using code. You just do some configuration in a particular file, and when you run it, you should bring up your server and your infrastructure without wasting your time. You can version it and then share it with your team members that they can use, even if you are not around. Even people that do not know how to code, if you share it with them, they can pick it up and run it, and then you have a new server. That is infrastructure as a code. So we have continuous integration, which I've explained before. We have continuous deployment, we have automated testing, we have release management, we have app performance monitoring, we have load testing and auto scale. So what we actually mean by load testing is, for example, now you have a lot of traffic. You need to be able to envisage that, oh, this application that I have, can it withstand 1 million hits at once? If you don't test all those things, you might have issues later. Because if you just develop an application, it might be very fast because there is a minimal data it needs. So it might be very fast, and then you feel that you have the best application. But within, let's say, next 2 months or 3 months, that there is a lot of traffic, a lot of records, data in the database, you now discover that your application is dragging. The reason is because you did not do load testing. So that's for that. So availability monitoring, I've explained that. Change and configuration management, which means if there is any change that you want to apply, you have to particularly, then you just fill a form, say whatever thing you want to do, and then they approve the change management. We have features flag, we have automated environments, deprovisioning, self-service environment, automated recoveries, and then we have hypothesis-driven deployment. So, wall of conviction. So that's basically everything I have to say. Thank you so much.
Okay, thank you.
Yeah, just a second. Thank you, Sulaiman, for that wonderful presentation. We're happy, and moving on to the next phase. So just in a few minutes, we would want to have a 10 minutes break. 5 to 10 minutes break would be, we'll be starting the live demo sessions in a few minutes. So let's just give us about 5-10 minutes, because this will be the longer version. So it would be nice if you could just go take a bottle of water or something, because this will be the longest time. Thank you very much. We'll be back soon.